All right, for this lesson, we're going to look at how we can write a linear inequality. This is for one of your TEKs. Usually questions are either going to be word problems or a graph, and they're going to ask you to write an inequality based on that. So looking at word problems, we want to make sure we read it all the way through first before we start trying to write anything down. That way we actually see what they want. So it says a bakery is ordering muffins and cookies. Each box of muffins costs $5 and each box of cookies costs $8. The bakery receives a discount if the total cost of the order is at least $90. Write an inequality that represents all possible combinations of boxes of muffins X and boxes of cookies Y in an order that qualifies for the discount. All right, so first off, I noticed they want me to write an inequality, and it's supposed to represent the combinations of boxes of muffins X and boxes of cookies Y, all right, in order to get this discount. So I know that for my inequality, I'm gonna have to figure out my total cost of the muffins and the cookies. And then if I look back earlier in the problem, it says the total cost of the order is at least 90. So that means I need to be greater than or equal to 90, because 90 is my minimum. I want to go over that in order to get the discount. So now we're going to look at how we can find that total cost. So to find the total cost, we're going to look at muffins and cookies individually. So for muffins, it says each box of muffin costs $5. And we said muffins was the variable X. So to find how much I spend, I've got to multiply how much they cost with how many I am buying. So that means I'm going to do 5 times X to find out how much I'm spending on my muffins. And then I'm going to have to add to that how much I'm spending on cookies. So for cookies, it says each box of cookies costs $8. Well, remember we said cookies was Y. So that's going to be 8Y to find my cookies. All right, and then those two together are going to make our total cost, and then it has to be greater than or equal to 90. And then that's as far as we go because it just wanted us to write the inequality. All right, now looking at example 2. A library is purchasing chairs and tables for a reading area. Each chair costs $20 and each table costs $75. The library has a maximum budget of $1,200 for this purchase. Write an inequality that represents all possible combinations of chairs X and tables Y the library can buy. All right, so once again, they want us to write an inequality. Okay, and they said we're doing all possible combinations of chairs X and tables Y. All right, so when we think about this for my inequality, I've got to think about how much I'm going to spend on the chairs and tables. And if I have a maximum budget of $1,200, that means I can't go over that amount. So I have to stay less than or equal to $1,200. So looking at the particulars, for the chairs, it says each chair costs $20. So I have to multiply how much it costs by how many there are. So that means chairs is going to be 20 times X. Okay, that gives me my chairs. And then I have to add to that how much the tables will cost. So each table costs $75, and I'm buying Y amount of tables. So this will be 75Y. So that's tables. And then I need to be less than or equal to 1,200. And then we're done there. Okay. Now, with the graphs, when we're doing the graphs, we need to remember slope-intercept form. All right, y equals mx plus b, except instead of an equal sign, we're going to use an inequality sign, and that's going to be based off of the shading and what type of line we have. So the first thing I'm going to do is I'm going to identify my slope and my y-intercept. So my y-intercept is usually easier to spot. It crosses the y-axis at -2. And then for my slope, I'm going to find another point that I can use to count with, which looks like right here at -3,3. So when I count my rise over run, I can see that going from that -3 point, I have to go down by 1, 2, 3, 4, 5. So it's -5. And then to the right by 3. So that has a rise over run of negative 5/3. So that means for my inequality, I know the right-hand side has to be negative 5/3 x minus 2. And I know I need a y on the left-hand side. Now I need to figure out my inequality sign. So first I look at the shading. I notice that my shading is above my line. So that means it has to be a greater than sign. And then I look at my line. Remember, dashed means it is not equal to. So we're not going to put the line underneath. And so that is my inequality. So we're going to repeat the same process for number 4. I'm going to start by finding my slope and my y-intercept. So my y-intercept is at 3. And then for my slope, I can see I'm going up by 1 and right by 2. So that's a slope of positive 1/2. So my inequality is 1/2 x plus 3. So now I need to just figure out my inequality sign. This time it is shaded below, it's shaded down from my line. So I need a less than sign. And then since my line is solid, I put an equal to. And then there is my inequality. All right, some things you can add is just a little cheat sheet of which phrases mean what. As you come across more phrases, add it to your cheat sheet so that you have it in the future.